Hello and welcome to another video that a lot of you have been asking me for. We're going to go over the new changes in Python 3.11. At the time, it has just reached beta, so usually that means a feature freeze, and so I can start talking about these features. But anyway, let's jump into it. Okay, so it's going to be a long one. We're going to take some notes over here so that you can hopefully follow along with what I am doing. Now, admittedly, this release, in my mind, isn't... I mean, it's pretty significant, but I don't know, I've been more excited for other releases. But we're going to go over the top 10 things, well, plus a few extras, that I think are really cool. And I basically got these by going through the what's new in Python 3.11 page. I've filtered this down to the things that I think are interesting or useful. And I'm going to go over small examples of each of them, or I'll link you to videos that I've already talked about. Okay, the first one, and the thing that I think is the most important, is 3.11 is significantly faster than Python 3.10 even, and way, way faster than previous versions. The way I usually show this is by making a little virtual environment and using the PyPerformance tool. This is the standard performance measuring tool that CPython uses to validate their changes, and it's been a big push of Python 3.11 to handle improving performance. We're just going to run one benchmark so I can show you this. I picked I looked through the list and I grabbed one that sounded interesting. I'm sure some of them are improving more or less than this, but we're going to use the Django template benchmark. Bin PyPerformance run -b Django template. And yes, I have notes because there's a lot to talk about today. So we're going to run the 3.10 one first, and then we're going to run the 3.11 one. And it takes a little while. It has to install some stuff and run some things. And I'm not going to run them concurrently because otherwise that is going to mess up the benchmark results. But when I did this before recording, this one was about 100-ish milliseconds, and then 3.11 was about 80 milliseconds. So looking at like almost a 20% improvement on just this little benchmark. Of course, well, 112. It's going to be even more than that. But some workflows improve more than others, and this is just one example of one that I thought was kind of important. And admittedly, this is the thing that I care about the most in 3.11. The rest of this, I mean, spoilers, the most important one is first. I guess we're going to do these in decreasing importance order. Oh, there goes all my video retention. No. Oh well, I kind of hate those videos where they string you along for some little thing at the end where I'll just give you the most important stuff up front. There are a few cool things towards the end though, so I guess stick around for that. Yeah, so 85 milliseconds versus 112 milliseconds. That's what? 85, 112. Like a 24% improvement, depending on how you measure it, which is pretty significant. They talk about some of the improvements here as well. Performance. Yeah, so there's a whole bunch of performance measurements in various places. You can see like some of the stuff here. Binary operations, subscripts, calls. Basically, they did a lot of specialization of opcodes and a little bit of like fancy caching for like globals and locals and stuff that makes things significantly faster. So check out some of those. But yeah, I'm not. that's the thing that I think is the most important. All right, let's talk about some actual changes. This one's actually not even called out in the what's new, but a whole bunch of work went into making this possible, and that is asyncio task groups. Now, task groups, or at least the way that I think about it, they're very similar in ideas to the concurrent futures module and what that did for the multiprocessing module. Basically, it gives you a convenient executor to run lots of things and join them all together at the end. So this is what you would do previously with, or this is what you would do with like thread pool executor or process pool executor versus the multiprocessing module where you would have to manually use either the process class, or you would use pool.map or map. Yeah, where you would have to do like kind of some low level, not really nice looking things. But the task group, which is new in Python 3.11, which is borrowed from EdgeDB, so originally from EdgeDB, makes this a lot more convenient. I'm going to show you a small example where we show what the code looked like before. So this is kind of a replacement for asyncio.gather. And admittedly, I am not super well versed in asyncio, so this, you know, is not quite the best coming from me. You're probably better to get your async stuff from someone else, but let's just say that we have simple main function, and what you would do before is, let's say we had async def f1, which takes an int, returns none, and does, I don't know, await async io.sleep x divided by 10, and then print hi from I called it x. So what you would have to do before is you would have to build up a set of futures using this. See I for in range 5, and then you would do await asyncio.gather star futures. So this was a little bit clunky to work with. It of course, you know, works fine. If we run this over here, Python 3.10 t.py, you'll see that it you know, awaits on all of these, and I guess we should print done and then return 0 or something like that. So if we this, you can see that it runs all the features and eventually gets them working. This is pretty clunky, and it means that you have to collect them all into one place when you call gather. It doesn't give you the flexibility to call, you know, other functions or do loops or conditions or all sorts of stuff. You basically have to get a bunch of features and then jam them into gather, which wasn't great. So task groups provide a more convenient way to handle these. So instead of doing something like this, we'll just comment this out really quickly. You will do async with async io.taskgroup as tg, and similar to how, you know, concurrent futures made the code look a lot nicer, task groups makes the code look a lot nicer. For I in range 5, 6, 5, whatever, you will do tg dot, what is the function called? Let me check my notes. Create task, and you know, you'll be able to do, you know, loops, conditions, etc., and basically push them into this task group. This with statement will cause them all to run to completion before the context exits, and basically executes the same way as gather does, but it's a much more convenient way to do things. Oh right, of course, we have to be in 3.11 because this is a new feature, and you can see that it works basically the same as how the gather would work, but it gives you a lot more flexibility into how you can schedule your task. Okay, and with task groups, so that's number 2. The third is exception changes, and there's quite a lot of exception changes. But the first one is actually related to task groups, which is exception groups. And it basically gives a new way to represent exceptions in asyncio, where you can have lots of different coroutines and they can all error in different ways. Previously, I don't even know what it did previously. but it was a mess to deal with. So now there's an exception group which collects all the exceptions together and allows you to handle each of them separately. Let's do an example of this. F2, which is just going to raise assertion error. Let's do type error or value error. And we're going to add that to here, tg.create task F2. Actually, let's create 2 of those. And we'll make another one as well, async def f3, and we'll do type error for this one. Sure. Create task f3. And so we're actually getting 3 different errors here that are all being handled in the background, and they'll eventually bubble out of this task group here. And either we need to handle them or we need to let them raise. We run this. And then this actually demonstrates 2 of the things that I wanted to cover here, which is that exception groups give you all of the exceptions, so you can handle each of them here. This is the new output, which is a little bit wild. Raise me from none. Okay, cool. That's a nice way to put it. But we have this brand new exception group, and this is what the syntax looks like if you're, or what the output looks like if you don't catch it. You might also notice that there's these new arrows. That's another thing that I wanted to call out in exceptions. This is new for all tracebacks. This isn't specific to asyncio, but there will now be arrows pointing at the exact expression that caused things to error out here. So you can see here like the main expression here, or there's not any really good ones here. Let's actually change this to, let's just do some math. 2 times 3 times 4 times none. Something like this. So we can see here that this is specifically what raised, and it even points out the operator that was the problem. So you can see there's these nice little arrows to point at each of those. But I wanted to talk about exception groups. Exception groups allow you to collect together all of the sub-exceptions that happen as part of running coroutines. And you can see we got 3 of them here. We got this type error, we got these 2 value errors, and they all are represented inside this exception group. Now, if I read the PEP correctly, you can actually capture all of them using exception group. Just using the normal using the normal except syntax. That's correct. Yeah, so well, that's weird. I don't know why that's printed. I guess oh, okay, I see. This is the representation. Got it. That's what EG is. EG is our exception group, which collects those 3 exceptions together. This is how you could handle exception groups in old syntax, in the Python 3.10 and previous syntax. But there's actually a brand new syntax for handling each of these exceptions separately, and that is the except star syntax. And it basically allows you to collect exception groups of each of the types of exceptions that might be handled here. So let's do except star assertion error. We're not actually going to be able to catch any of those. And let's see. EG. We'll just do some repeats here. Assertion error. We're also going to catch value error, and we'll let the type error bubble. You usually don't catch type errors. So what this except star syntax does is it's going to capture anything of this type, and of course you can list as many types as you want here with the same except syntax as you would use before. And it's going to assign them into an exception group here that you can handle specifically. This allows you to handle a particular type of exception here. And if this stuff sounds complicated, it is. I don't even completely understand it. It's kind of a mess. And admittedly, I feel like they didn't need to add new syntax for this, but to each their own. So if we look at this, like I think they could have gotten away with just raising exception groups and allowing you to manipulate the exception group directly rather than having a brand new syntax. But to each their own. So you can see here that we handled this actually. Well, let's just put BE and AE here. You'll see that when we run this, we have actually handled the value errors inside of a exception group with 2 sub-exceptions. Off screen there. But the one unhandled exception, this type error here, still bubbled out as an exception group. So you can see here there's still an exception group raised out of this task group here that has that original exception. So you can still bubble stuff out of an except star block, similar to how except works. But it allows you to iterate over each of the exceptions and handle them separately in here. And you can re-raise them, and there's like a whole bunch more complicated stuff that you can do in there. So that's the basics of exception groups. And yeah, the syntax for this is a new except star keyword. There's a little bit of a quirk here in that the parser doesn't actually handle this as a keyword, so it actually handles it as an except token followed by a star token, which allows you to do some dumb things like this, but we'll just pretend that's not a thing. Oops. But yeah, so now we can have the same argument about, does the star go with the type on a pointer or does it go with the name? We can have that same C++ or C argument again. But anyway, so that's Exception groups, the new except star syntax. We also talked about the arrows. There's one other thing to exceptions that's new, and there's now a way to add notes to exceptions. Let's actually unhandle this so that we see everything that happens here and just show you the absolute chaos that is brand new exceptions. We're gonna do async def f4, which is going to call f3. And if we get a type error, we are going to add notes to it. Now this doesn't seem that useful unless you think about some of the things that you might want to use this for. Well, that was a useless sentence. One use for this might be adding information to an exception as it bubbles. Like you might not have the information to change the type or re-raise it properly, but you might want to, give it some more information. This is actually inspired by Hypothesis, which attaches information about why the exception failed to the exception, but it doesn't want to change the original exception. It just wants to add some information. So I believe there's this add notes. I didn't actually pay attention to the right thing here. This failed while trying to blah. I don't know, something like that. And we're going to re-raise it here. Is that how this works? Why do I not see the notes? Where's the notes? But notes. Maybe notes are not maybe notes are not compatible with exception groups? I could have sworn that's what it was. Oh, we didn't actually call F4. Let's change F3 to F4. Add note. It gets stuffed into a double under notes. That's what it is. Okay, cool. So you can see here, we added notes to this exception, and when it gets displayed down here, the notes will be displayed directly after the exception. So you might, make a bulleted list or format them how you want. But this allows you to add information to exceptions without changing the type and without having to re-raise them in any particular way. Although we do re-raise here, so I guess it does change in some ways. And this gets exposed as double under notes inside the actual exception object, but hopefully you don't have to deal with that directly, and you'll just be using this to add information to re-raised exceptions. Okay, but you can see this is absolute chaos. There's a lot going on here. I am not too plussed about this. I feel like this is a lot to read, a lot to re-understand, and if an exception was thrown and looked like this to me, I might need to go for a walk and try and collect my thoughts on what the hell's going on. Okay, that's exception changes. Number 3. All right, number 4, and I'm going to bucket these all together because there's a whole bunch of them, and they could each be their own videos, and in fact, some of them I've already made their own videos about, are the typing changes in Python 3.11. I should go back to our notes. 3 is exception changes. We have arrows for expressions. We have exception groups for asyncio, task groups. We have add note for adding information. Okay, cool. Keeping up with our notes. Number 4 is typing improvements. And we're gonna start, I'm basically gonna go down a list of some of the stuff that I have here, and I'm gonna briefly show examples of each of them. So the first is the self-type, and I actually did a video on this, so I will try to remember to link that in the description. But what the self-type allows you to do is it allows you to make methods which were hard to represent previously. So for instance, a cloning method, a method which slices the object and returns itself. Previously, if you've had written something like this, then when you inherit from D or from C, then d.clone would be a C type according to the type checker. But this self annotation allows us to correctly forward the type to the actual class that we want. So now that we've done that, we get D. And I go over this in more details in the actual self video. I think this is optional, so you can actually leave it out and it'll get inferred. I don't remember specifically, but I'm pretty sure that's the way it works. You can also use this with class methods. So if you have like a make method which takes in arguments and returns itself, you can use this, and this will also get propagated through inheritance. Of course, you would write this as type self if you had to actually write out the annotation, but I'm pretty sure it's inferred. I don't know. Check the video. I'm pretty sure I go over it in there. Although the type checkers didn't support that, so I don't actually know. Okay, so that's self. Allows, I guess, methods to return the actual class. Useful for cloning and alternative constructors. Yeah, things like that. Okay, so that's self. The next thing that I want to talk about is variadic generics, and I have a whole video on this that should have already come out by now. But this is typevar tuple and unpack and splats in types and variadic generics. And admittedly, I don't know that these are actually going to be useful for actual code, but they will be very, very useful for stubs. There is some talks about making them actually possible in real code, but we need some sort of map operator to actually make that happen. Basically, what a variadic generic allows you to do is it allows you to have multiple type variables. The most important use for this is going to be tensor types, things like NumPy arrays or TensorFlow objects, pandas, etc., where you want to represent an array that has multiple dimensions. TS equals typing.type. Well, we're not going to bother with imports, but because we're not actually going to run these. TS, so similar to a typefier, but you do it like this, and we'll have a generic of star TS. Anything that I don't import comes from the typing module. So this allows you to have a type that's like array, maybe the first dimension is an int, the second one is a float, the third is a stir. However you actually want to represent this, you probably wouldn't have int float stir, you probably have int float, but this might represent a two-dimensional array where you have the y-axis being an int, the x-axis being an int, and the values being a float, for example. And this allows you to represent things that are whatever dimension you want and to build functions that transform them. So if we had like, I don't know, a double function which took an array of some type shape and returned a new array of the same type shape, this may be something that you would do there, for example. It may also be something where you like add dimension, a array star TS, which returns a new array with a new type on the front of this. And I go over this in more details in the actual video, but it's kind of the basics of it. There are also a couple new fancy things that come out of this as well. Notably, this star can happen inside tuples. You can also use this inside star args to type a star args. So some of the examples of that are like if we had t being a type alias for tuple int, and we wanted another tuple that added onto this, we could say t2 is also a type alias that is tuple star t and then float stir, and this would actually show up as tuple int float stir. So you can use this to kind of compound things together. You can also now represent a type which is a variable length tuple with a fixed length prefix or postfix. The syntax for that is a little bit clunky. And the way that works is you can splat. Let's say we did something that starts with a string and then has any number of integers after that. You can splat a subtype inside of it. So this is a type that represents a single string and then a variable number of integers afterwards. This is useful in a few places in the standard library. Like one example is in execv, where you want to represent a variadic set of arguments, and you want path or whatever to be at the beginning that are different. The other thing this is useful for is star args, which you can now type using this splat operator. Only single star args. I think double star args is planned for typed dicts, but it's not implemented in 3.11, so I don't know too much about that. But if you can say like star args star t3, and this would represent a function which takes a string as its first argument and then any variable number of integers. So you could say like as star int equals args, and the type checker would know that this is a string and then these are all integers. Assuming the type checker has implemented this, of course, MyPy has not done this yet, so look out for that in the future. Okay, that's a crash course of variadic generics. I go into this in much more detail in the other video. I'd recommend you watching that instead. Okay, variadic generics. All right, the next one is literal string. And this is actually a really cool thing. We had this idea years before Python did. I actually did a puzzle video about how to implement this using a MyPy plugin or using a Flake 8 linter. So I will try and remember to link that in the description. But basically what literal string allows you to do is it allows you to make a function that has to be a literal in source. And why would you want to do this? One example is to use the type checker to enforce or to ban SQL injection, to force all of your queries to only come from literal strings rather than formatted string. So you could say like execute query. Now granted, you should probably use some sort of query engine, but something like this, and you'd actually list your return type here. But this would allow something like this: execute query select star from users, but it would ban something like this: select star from either an F string or a format string, or something where this would be a potentially unsafe call because we haven't made the string an actual literal. We've allowed it to come from some outside source, and maybe there's SQL injection here or other stuff like that. Another example where literal string might be useful is if you're making an internationalization framework and you want to force that you want to enforce that it's possible to parse the strings out of your file without having to do some sort of string formatting, because internationalization frameworks tend to not do well when the message ID is formatted. You usually want that to be a constant static string and allow the actual internationalization framework to do the formatting. But this can be useful for SQL injection or preventing. Oh, I realize this is off the screen. So that this into there. Oh, I forgot to talk about unpack. Unpack is the backward compatible version of Splat. I go over that in the other video. Okay, preventing SQL injection, IETN frameworks, etc. This is internationalization, but a numero nim. Okay, so that's literal string. The next thing is the never type and assert never and assert is instant, or assert type. The never type is just a new alias for no return, but it reads better when you're reading out types. So for instance, if you have something that either always raises an exception or never completes, you can say like f returns never. And this is, if you want to do it in old Python or old typing, this is the same as doing no return. And I did a video on no return in God, really long time ago, early part of my channel. So I'm not going to rehash that here, but basically this is a function that always raises or loops forever, or replaces the process or something like that. Basically the control flow is never going to flow outside of this function. And there are two new assert helpers, and these are actually kind of neat. Previously you can convince the type checker about things by saying assert x is not none, for instance. Maybe you have a function which returns an optional, and you want to convince your type checker that oh, it's definitely not none, but you want to continue to validate afterwards that like hello plus x. I of course wouldn't use plus here, but I wanted something that errors when it's none, but I've got a space here. So this is how you used to do this. You would tell the type checker, hey, it's not none, I promise. But in some annoying linters, they will claim that assert is a security issue, which I don't really agree, but to each their own. Some people will assert that assert is a security issue. But and I've talked about that in another video. I'll try and link that in the description too. God, I'm gonna forget all the videos, so search the playlist if I forget any of them. But now there is an assert never, which allows you to basically make an assertion that something is not going to happen, such that a type checker can use that information later on in your program. And basically this is the way it's defined is an overload that returns never when this is true, and It handles it when it's false, or passes through when it's false. So it's basically a way to explicitly hint to the type checker something that should or shouldn't happen. And similarly, there's an assert type, which I believe looks like this. I don't know the actual syntax of it, but I think it's like this. And this replaces those assertions for isInstance. And this is kind of the most common case where you would check types inside of your program. I believe these still occur at runtime. I'm not 100% certain of that, but they're hints to the type checker that help you basically write code that is more explicit about why you're asserting these types. Okay, the other typing improvement that I wanted to call out is some of the types that you would extend, some of the sort of magical types can now be generic, and those are typed dict and named tuple. Previously, they were not allowed to be generic, but they shuffled around the inheritance hierarchy and made it now possible that these can be generic. So if you had like class typed dict, you can now do generic stir and say, or generic t, and you can use generic types inside of your typed dictionary. You can also do this in named tuple. This was not allowed before, but now it is. Super minor, but kind of neat. Okay, that's typing improvements. That's number 4. Oh god, we're 30 minutes into this video. We're not even number 5. Okay, on to number 5. The last ones are a lot quicker, I promise. Okay, number 5 is the introduction of the tomllib library, which is good and bad. We'll put it that way. So TOML is a configuration format if you're not familiar with it. I don't know how you would be unfamiliar with it. It is basically similar to INI, but has structured types. So you can, have strings or numbers or whatever, and they're represented as a text configuration format. And now there is a parser in the standard library. Note that I mentioned there is only a parser for now. It's not a writer, which is a little bit annoying. And the parser has basically 2 useful functions. There is loads and load. And annoyingly, loads only allows stir, and load only allows bytes. Which I can kind of understand why they did this. TOML has very strict encoding and new line requirements, and you can't really enforce them without those. So, if it allowed stir, you can still pass it as stir through your. I don't know. I can't rationalize why they did this. It just seems like a annoying API for no good reason. But let me show you the error message and show you like how this can go wrong. Import tomllib.loadf. So load is loading from a file, very similar to the JSON API. Oops. Try that again with open t.toml as f, tomllib.loadf. So you can see here that when we get when we have the wrong type, it tells us to use it in binary mode. We try that again, but in binary mode, see that we can actually load this file, tomllib.loadf. And so you can see here, we get the right types out. We get an integer, we get a string. Now, if we instead try to use tomllib.loads, and we're going to also just reuse that file as f, tomllib.loads f.read. So this works fine. But if we were to use the binary file, we get a different error. And actually, I think the error message will hopefully improve by the time this lands, because the error message for loads when it's a binary string is a byte string. Binary string is nonsense. Read. This error message is a little bit weird. A bytes-like object is required, but I sent a bytes-like object. So hopefully that'll improve. But this is a loader for TOML. So now that's part of the standard library. It's based on the toml.i library. toml.i. And there's no writer. If you need a writer, you'll have to pip install toml.w. toml.w or any of the other TOML readers and writers. There's 10 or 20 of them on PyPI. So that's the TOML library. Okay, the next one, this one also isn't called out in the changelog, so getting a little bonus content here. But I'm really excited about this next one, and that is contextlib.chdir. Oh, I've written this function probably 100 times now. But this is a context manager that changes your working directory and changes it back when the context exits. So for instance, import contextlib, and we'll also import os. os.getCwd with contextlib.chdir. Let's just change my home directory, for example. Print os.getCwd, and then we'll print it after it goes out. So basically just a very simple context manager that allows you to change the working directory. I've wanted this for so long. Let's see. All repos grep dev chdir in Python files. How many times have I written this? Oh, actually fewer than I expect. Huh. Okay. Oh, I might have called it CWD. Yeah, okay, so a few more times. Basically, I've written this function many, many times. And yeah, now it's in the standard library, so I don't have to write it anymore. Changes working directory and back. Now, note there's a few caveats to this, like working directory is a global property of the process. So this is not thread safe, this is not async safe, etc. This is really only intended for single-threaded code. And yeah, so be careful with this, but if you're running single-threaded code, it's a thing. Okay, the next thing that I want to call out is changes to the RE module. There are now atomic groups and possessive quantifiers. Now, this probably doesn't mean anything to a lot of people, but these are some new features to allow you to write more performant regular expressions. This was possible before, and actually, I wrote a terrible thing for this while I was writing my text editor. Archive, text made highlight. Yeah. I wrote a terrible thing for this in my text made highlighter, where I was originally trying to change a different regex flavor into Python's regex flavor. So here is an example of where I convert into possessive quantifiers, which is completely unnecessary now. I guess I should tell you about what they are. Oh my god. Notification. Whoops. So atomic groups basically are all or nothing. There is no backtracking. They disable backtracking in the parser. And they look like this. They are a group, and they have some sort of regular expression in here. And the regex engine will try and either match this, or it will fail the match entirely. And if we grab a little example of this, reg equals re.compile, let's see, checking my notes here, A, and then a atomic group for BC or B, followed by C. Okay, so this will match A, B, C, C, but it will not match A, B, C, which would have been matched if I did not have this special atomic group here. And the reason that it doesn't match this here is the regex engine basically processes like this. It'll match the A, which moves the position forward. Then it will try BC, it will match this. Then the atomic group will be closed, so it has succeeded in some sort of match. Then it will try and match C and fail. There's no C at the end of the string here, and so the entire match will fail. Whereas if this were not a atomic group, it would match A here, then it would match BC, then it would notice that there's not a C here, so it would backtrack to the beginning of this group and try this branch instead. It would match a B, and then it would match a C. So atomic groups are a way that you can control backtracking very specifically. So it allows you to write a more performant regex. I'm sure you've seen npm install, and it's like, oh, warning, critical security because regex backtracking, catastrophic backtracking. This is a tool to help you prevent that. In the same way, there are also possessive quantifiers. These also help you prevent these sort of catastrophic backtracking situations. And the way those work, there's a couple syntaxes for those possessive quantifiers. Basically, you put a plus on the end of any previous repeat. So you can have plus plus, you can have star plus, you can have question mark plus, and you can have, if you have your n repeater plus. And this special plus here basically enforces a possessive quantifier and works very similar to an atomic group. It will try and match the entire thing, and if the expression after it fails, it doesn't backtrack to the beginning. So it allows you to write repeats without backtracking. And of course, you can implement this with atomic groups, and you can also implement atomic groups with back references and look aheads, but we're not gonna go over the way to backport those. So I wanted to show you a quick example of this as well. re.compile, we're gonna make a regex that is double quotes, and then dot plus plus, and then double quotes again. And so this is admittedly not a very useful regex. I actually don't think this can ever match anything at all, but it's useful for demonstrating the example here. So let's say that I made a double quoted string here, foo. If I didn't have this special plus here, this would match the double quote literally here. Then it would match any number of characters. It would match this thing here, the whole rest of the string. Then it would notice that there's not a double quote here, so it would backtrack. And then it would match this as this inner part here. And then it would match the double quote. But with possessive quantifiers, this dot plus plus causes it to parse this entire part out here, and then it never backtracks because that's what possessive quantifiers do. They don't backtrack. And so it would fail matching the string there. Just to show you another example, we can represent our proper double quote, our string matcher here by saying, match anything that's not a double quote. And this works similarly to how you would do this without plus plus, except it will never backtrack. So if there's, if it has to try a whole bunch of times, it will not try at all. It would try once, and if it fails, then it fails. So now if we do reg.match, you'll see that it matches. And so those are possessive quantifiers and atomic groups. These are really powerful and will allow you to make more performant regular expressions. Okay, on to the next thing. This is changes to datetime. From ISO format now understands much more of ISO 8601, so you can parse a lot more date formats. This is really cool. I'm really happy about this because parsing dates sucks, and letting the standard library do more of it is a good idea. So I'm going to take a little date string here that we couldn't parse before in Python 3.10 just to show you that. Datetime.from ISO format. This datetime string, you can see that it's invalid here. But if we do it here, from ISO format, extra quote here, don't want that, you'll see that it's able to parse this datetime string with a time zone. And the with a time zone is actually really, really interesting. So this is one of the few places in the standard library where it'll take a string and turn it into something that actually has a time zone attached to it. I think you can use like t+1. I don't remember the format for it. Oh, is it here? I don't know. Anyway, ISO 8601. Parses more formats, can include time zones, which is pretty cool. All right, that brings us to number 9, which is sys.exception. I guess I could have bundled this in with the exception changes above. This is just a very short one. Try raise. We're gonna raise an exception. So one way that you could look at the exception information before was by sys.exception_info, and this would return the type, the value, and the traceback as like kind of this 3-tuple, and the standard library would use this 3-tuple all over the place. And it's a little clunky to have to keep 3 things around for an exception. So if we do this, if we run this, 3.py, you'll see that we have the class, we have, well, we can actually see the object there, but let's put repr around it for all 3 of these. You'll see that we have the type, we have the value, and we have the traceback. So you kind of have to keep track of 3 of these things. Now, the observant user would be like, well, wait a minute, we have the value. Surely we can just derive the type from that. We don't need to keep the type around. Yep, you're right. You don't have to do that. And a more observant user would say, wait, didn't they change tracebacks to be part of the exception object back in like 3.4 or something? Actually, it was probably even earlier than that. And yes, you would be right on that as well. So if we look at this, we can actually reproduce the entire thing just from the value. So if we did print wrapper type value, and we would do wrapper value and wrapper value dot traceback. I think it's traceback. t3.py. Yeah, you'll see that we're able to reproduce exactly the same exception triplet, but just with the exception object itself. We don't need all those parts. We could just use the value. And so now in Python 3.11, instead of having this triplet, you can now just get the value back. Equals sys.exception, and the exception info is now, soft deprecated for sys.exception because this is much more convenient. Copy this out and run this in 3.11. You'll see that we're able to get back all three of those values. So, and internally inside of Python, they've switched over those triplets to exceptions in a lot of places. Okay, that's sys.exception. The last one, number 10, there are honorable mentions. We'll mention those afterwards. This is a step in the right direction for unit test. Now, admittedly, and I'm a PyTest maintainer, admittedly, you probably don't want to be using unit test in 2022, but this is a convenience that's super helpful. There's now an enterContext and enterClassContext, which makes it a lot easier to write correct tests that set up and tear down things properly. So easier setup and teardown. So imports unit test, class test, thing, unit test.test case, test thing, and we would maybe do a setup. I think that's the syntax for it. And now you can do self.enterContext, and let's say that we had, I don't know, we'll use the one from before. Yay, new features, contextlib.chdir to, I don't know, something like this. And let's actually show that it works. And so this enterContext will know to call the context manager and do that as setup information, and then later it'll automatically tear down that exception as well. And you can use this with any sort of like database fixturing or other stuff like that. But it's really nice because it uses context managers. This is actually very close to how PyTest fixtures work, where there's a yield in the middle, a context manager. Super nice. So if we do, what is it, Python 3.11 unit test discover t4.py, is that how this works? Start directory is not importable. t4.py? Test thing has no attribute enterContext. Did I forget to wait? Wait a minute. Do I have the wrong name? Added enterContext of test case. What? What? Well, I thought that was supposed to work. I don't know why it's not working. Anyway, I will look into this after the video and figure out why. Maybe maybe it was just after beta or something. Or yeah, that's weird. Hold on. grab-r enterContext user lib 3.11. Weird. Was it backed out? Now I'm gonna have to edit video. Yeah, weird, it's there. Huh. 3.11 beta 1. Oh, it must have slipped in right after the beta. Sneaky. Okay, well, it'll be there in the next beta, I guess. That's why it's not there. But yeah, it allows you to do context manager setup and tear down. Oh, that's a bummer that they would sneak a feature in after beta freeze. Well, that's kind of against the thing. Anyway, okay, now on to honorable mentions. Honorable mentions. These are just a few other small tidbits that I think are cool. Or not cool. There's this new Python safe path, which I I think is poorly named, but it does a thing nonetheless. So this is the default path that you get when you run Python. And there's now a brand new --P, which makes the path safe. Now, I think anytime you name something safe or fast or unsafe, like there should be alarm bells going off that, maybe that's not the best name for this. But what this really does is it eliminates empty string from the path. So it prevents you from importing from the working directory. This is important if you change working directories or if you have untrusted code in your working directory. I guess, it is kind of somewhat safer without it, but there's other ways to inject code that this doesn't really address. So that's new. This is also --P, or you can set it as an environment variable. I don't think anyone will actually use this, but it is a thing that exists now. Another thing is wsgiref.types. This is a new set of type aliases that are now part of the standard library, which make it a lot easier to handle typing a WSGI application. Writing these out is a real pain in the butt to do correctly. I've had to do this myself. API gateway v2 to WSGI, which fortunately I can just dump all of my simulated versions of the same type aliases, and now I can just use wsgiref.types, which is pretty cool. Types aliases for WSGI apps. And another honorable mention is singledispatch. Now understands union, so the typing union or the pipe union. So singledispatch is, I think it's a functools. I don't know. Singledispatch. It's basically a way to write single dispatch, basically a function that takes a bunch of different types and calls different versions of those functions based on the type. So for instance, like if you have a list or you have an int, you'll be able to register a bunch of different functions and have them get called back based on the things that you pass into it. It now understands unions, so you can use union types here to single dispatch, which is pretty cool. But yeah, that's my top 10. Well, actually 11 plus a few, and there's a few extra things in here as well. This is the most important things, I think, for Python 3.11. I hope you enjoy this. If you somehow stuck around to, oh my god, this is a 50-minute video. But yeah, if you want to check out what's new in 3.10 or 3.9, I'll also link those in the description as well. But thank you for watching, and I will see you in the next one.